Go to it, Mike.
Yep. All right, ready to go? Let's rock and roll. Good morning, good evening, and good afternoon, everyone. Welcome to our September Garden State Java user group meeting. As much as I would have loved to have been there today, I had to stay home because we have contractors working on our house, and that's a very long story. Also, my semi-co-host, who is in the cat tree behind me, probably knew we were going to start the meeting, so she took off. So she can't be in the video. But so anyway, and without further ado, let's start things off as we usually do. So share my screen. And of course, I'm on GoDaddy, but there we go. So now we're all set. All right. Give me 1 second to move things around. All right. All right. So our usual agenda, for those of you who are regulars, know the routine. We thank our sponsors. We talk about what's new. After that, I'll introduce Marcus, and I spelled his name wrong. Oh my goodness. He'll do his main presentation, and we'll talk about some upcoming events, including an opportunity for a free ticket to a conference in New York City on October 24th. More details later. And then we'll talk about some upcoming events from us. We have meetings booked through January of next year. So our sponsors, Azul is our silver sponsor. So we thank them for their support, and check out their downstream distribution of OpenJDK, which is Zulu, but that may have changed. But they're one of the vendors, along with Bellsoft, who implemented coordinated restore at Checkpoint, also known as Crack, in their OpenJDK builds. Our partner is DevNexus, and the conference for 2025 is scheduled for March 4th through 6th of next year. The call for papers actually closes on the 15th, and I noticed this today, and I better get on the stick here to put together an abstract. So for those of you who might be interested in doing so, that is the deadline. And if you go to devnexus.com, I think it is, you'll see the info for submitting an abstract. Our per meeting sponsors is JetBrains. Of course, they provide us with licenses for IntelliJ IDEA. Also, the Eclipse Foundation and Jakarta EE, they provide conference hosting with their Crowdcast software. So we thank them for making this available for all Java groups, whoever wants to participate. All right, our memberships, we're a member of the Jakarta EE ambassadors. We're also the microprofile working group, the Jakarta EE working group, and the virtual jug. And in case you don't know who the heck the Jakarta EE ambassadors are, we're an independent grassroots group of folks committed to moving Jakarta EE forward through active community participation and advocacy. And boy, do we do a lot of that around here. This group evolved from the Java EE Guardians, which came out in 2016. So, and then the Leadership Council, I'm the vice president, and Ryan Kuprak is the president. So you can learn more about us at that URL below. All right, so what's new? So JDK 23 will be released a week from today. There's also a streaming event that Oracle will be presenting live. This will start at 9 o'clock Eastern, and you're going to have all the usual dev advocates. You're going to have Nikolai Parlog. You're going to have Anna Marie. You're going to have Billy, and all those guys, along with other folks. And this will probably go for about 3 hours. So if you have time to watch that, that'd be great. Jakarta EE11 still a release date has not yet been determined. However, the TCK refactoring is about 50% complete, according to Ivar Grimstad's blog from the other day. So hopefully we'll hear something soon. And one thing I forgot to put on this list for last month was this nullability in Java. This seems to be something that's emerging. There's this group called JSpecify, and they have their own product with 4 annotations that have to do with null in Java. So Ben Evans, who was the previous lead InfoQ, JavaQ, wrote both of these. They came out within a couple of days of each other. So if you're more interested in more of that, please head over to those URLs. So Ben's an awesome writer, and I had big shoes to fill when I took over for him as the lead 3 years ago. All right, so the features real quick. You can see them right here. I'm not going to go through them. That's the first half. And then the second half is here. JDK24, which will come out in March. I think there's the restrict JNI Jeff that's been targeted so far. And then these are the finalized Jakarta EE11 specifications. And that's the other half right there. So, and of course, I mentioned this a couple of times. I use this application written in Java, of course, for entering names for drawing a winner for the IntelliJ IDEA licenses. I finally realized, I said, geez, I should put this out there for everybody to see, how we do this. So, anyway, if you see something that needs improvement, please let me know. All right, so Marcus Hellberg, and I forgot to bring up his bio. I'll do that quickly here. All right. So passionate about both learning and teaching, Marcus Hellberg helps developers learn the skills they need for modern full stack web development. His talks often explore the integration of Java with front-end technologies and delve into how developers can make the most of AI tools with their applications. Marcus's teaching approach is hands-on, emphasizing practical coding examples. Beyond technical topics, Marcus brings years of experience in developer relations to discuss how a strong DevRel strategy can create value for both developers and businesses. And Marcus, if I'm not mistaken, you're the VP of DevRel over at Baden, right? So without further ado, I'm going to mute myself and we'll take it away.
Take it away.
Okay, are we good? Is audio good? We can hear us on the screen.
Mm-hmm.
So never will it happen. All right. Thank you so much, everyone, for coming. It's awesome to see so many of you here in person. It's always fun to share stuff that just meet with people in real life. So you see, my name is Marcus Hellberg. I'm a certified human person. And we're talking about the next step of this, like basically human interaction with the website about. So I'm very curious by nature, and this AI kind of stuff really started happening a couple of years ago. I find really curious just play around with it and try to understand what I can do with this, how can I find something that's relevant to my interest. So I know it means to have a data scientist or anything, I'm a developer sharing my experience to you, other developers, and hopefully we can learn something that's not only kind of interesting, but something that's actually practically applicable, something that you can take from here and go and do it on tonight if you want to. So, this here is my dog Nova. He's almost 12 years old now. She's an old lady. As old ladies go, she has some aches and pains. So, almost a year ago, we had to take her in for CT scans. She had something weird going on with their back, and wasn't really sure if it's something with their spine or not. And went in for the CT, and we, for some reason, the radiologist decided that the best way of delivering the report of the CT scan to us was basically printing it out on a letter size paper, kind of a point font, like one single spacing, super dense text, like medical jargon, just print it, put it on They will take a picture of his phone, send it as a text message with no explanation. So they're trying to decipher this thing, did not understand what's going on. So as a nerd, what can I do to make some sense of this? So I think ChatGPT, thanks to act as a radiologist who is not only very skilled at their job, but also capable of communicating with other human beings. And please read the report and explain the kind of key takeaways and how easy to understand. Sure enough, I got 3 main bullet points and like what's going on, it's reading that in the printout, you know, nothing very wrong with her, which is good. Sure enough, the technology called 4 hours later and told us the same thing, but that was a lot of not worrying to do there. So I think when it comes to AI, there is like we've already seen that there's a tremendous amount of like possibility, good things we could do with it. But also, if you've ever used ChatGPT for anything meaningful for a while, sometimes you kind of get stuck in there, like, how can it be so stupid? This is a very simple thing that I'm trying to do, yet it's doing something very unexpected. So, on a very high level, if you're completely unfamiliar with AIs and LLMs, they're very simple. You ask a question, then magic and unicorns happen thinking, and you get an answer. The big problem with them is that they're general purpose tools. They're very generic in how they do it. Whereas what we're trying to do in our businesses, our hobby projects, our personal interest things, they're very context specific to what we're trying to achieve. Right? A general purpose, like language model, may not have any idea of what we're trying to do. So I work at a company called Broadening, as Mike said, and what we do is we help Java developers build web applications. So we have all kinds of tools and components and frameworks for that. A lot of Java developers to build web apps. More specifically, people tend to build business applications. So these are not the cool apps on the App Store, but these are the apps that run in the back of the house companies and actually make them run. They're the apps that make the world run. And what I've noticed over the years is that there's just a tremendous amount of inefficient workflows happening in these applications. There's a lot of people sitting in cubicle just doing stuff from one place to another, doing very kind of non-inspiring work. Where I think applying AI in smart ways would really help us kind of both make things more efficient, but also kind of more enjoyable for the people who are interacting with the system. So that got me exploring how could we use the AI tools that we have available to us to build something that's kind of meaningful and actually helpful. So today, what we're going to build together is a little airline reservation system. So we have effectively a live view of the database of reservations and have a stimulated customer support agent that we can interact with. And what we want to be able to have this chat agent do is both understand our company's terms of service, what's allowed, what's not allowed, what are the policies, and so on. We also wanted to be able to access our database for the check and look up a reservation, make modifications to it, and actually interact with that system. So it's not just generating funny jokes or something else, but we're actually integrating into our business application. One thing that's helped me kind of understand how to put together these pieces as a computer is thinking of building AI apps sort of similar to a computer diagram. So, like I mentioned, a large language model is a fairly generic thing, but it's very similar to a CPU in a computer architecture where it's very powerful, but in and of itself, it's not super helpful. So, at a very minimum, we need to have some sort of working memory, kind of a context window and kind of like that. So that's somewhere where we can store what we're working on right now. So that it knows what we're discussing about, we can feed it all the information like that. Very soon we run into a situation where we want to store things for later on as well. So we have an integral vector store into this, so we'll be able to kind of pull up relevant pieces of information and give that as part of the episode. Very soon we also I want to give some force to that whole link so that it can perform access to it, like going without those skipping details or something else in the example. Very likely at some point you might want to give it access to other APIs like search the internet or maybe follow other LLMs that you use to ChatGPT to generate an image. Especially one LLM first writing a really elaborate content, data over another LLM, which actually, or not LLM, but a future model that's trained on generating images based on text. So there are models that are getting out there things, and sometimes it's very good to have them discuss with each other. This is going to be a very engineer talk. Like I said, I'm not a data scientist, but I can do math, so I can call it that was we're going to focus on APIs. We're talking about language that we all kind of got to use. So we're just looking at the tools available to us and how we can have those application. Specifically, we're going to be working with the open source tool. One is called LangChain4j. It started out a long time ago, a year ago at least, as a kind of a work like Python project, but it's since then evolved quite a bit, where it's now really a core of that project, but it's pulled in kind of influences from all kinds of AI libraries with ideas like all over the place, and it's become a really kind of rolled up and supervised open source project where they collect a bunch of tools that they get really easy for as developers to interact with language models and vector databases and stuff without really needing to know how everything works out there. Then we're gonna put this into an application using the framework called Quality, which essentially allows us to build a first application that we would react and front end and the back end. We're going to be focusing today continue on the technology side of things, but I'll just show you like how the UI works. I'll check out the GitHub project later on. You'll have an understanding of what's going on there. But you can play around with this without understanding the front end part of it. So we're going to structure the talk along this axis of agent autonomy that I picked up from the Microsoft internal website. So essentially, we can kind of categorize AIs depending on how much autonomy we give. Yeah. So on the kind of lower end of the spectrum, we have a chatbot, which is essentially us just chatting with that LLM with kind of looking at the topic. So we can answer any questions that it knows about. If it doesn't know about something, it's just very helpful to make up stuff, but it sounds very different from doing it. Which is why we very often end up finding ourselves in this retrieval-augmented generation or RAG stage. Retrieval-augmented generation is just that we retrieve relevant information, whether that's from the vector data, the internet, or from any other source, and we pass it in to the LLM as a context that essentially like answer me with this information. And that's going to make it a whole lot more useful for giving us relevant information. Now, if we take things one step further, we have a profile execution. So this is where we're going to end up with this stuff. So we're essentially giving the AI that's kind of a limited amount of tools that we were saying, like, hey, you're allowed to use these tools when you're answering. So if you need to perform some actions for us, you can use them. And that's essentially, we're still in the pilot seat. We're kind of deciding what it's allowed to do, what it's not allowed to do. But we're also saying like these are some very simple things that you can go ahead and do for me, right? You allow them to do it. If we were to go all the way for the autonomy, which is the name suggests, we would probably AI to go that serious by filling my taxes and let's see what happens. Might not be very real. I very much believe that the foreseeable future, like when it comes to especially like this applications, we're going to be going to profile stage where we as humans still want to have some say into what's happening. We want to be able to verify that it's doing seriously with things and working the way we expecting, but surely we'll end up in some kind of context in the world that was fully autonomous state at some point. All right, so we're gonna structure this in a way where we're going to quickly look at some theory, just because I don't know what your background is in terms of building AI applications, and I want all of us to understand the kind of general concept we're putting together in this application, but then the rest of it will be kind of live coding. So I'm sure hopefully at the end of it, we're left with a working application. Just out of curiosity, how many of you have already built some sort of AI application? Okay, one person. Well, this is going to be awesome. So we're going to train whole room full of AI engineers by the end of today. So if we start with a chatbot, so this is us talking to that LLM, including a context window for that network. The way looking at this context window is sort of around the people. So this is kind of where you need to store everything that's relevant for your current ongoing discussion. Now, a context window is typically measured in tokens, tokens being these words that are nice to discuss that if you want to not super relevant for this fact to understand what they are. But it's kind of good to understand that there's a limited amount of the space that we have available to what we're doing. Within that space, we need to fit many things. So first of all, we need to have a system bump very often. That's in my earlier example, that's what we tell ChatGPT to have as a radiologist that's like capable of communicating with you. So that's telling you how it should be done. We need to keep track of our chat history, so everything that's going back and forth, we need to talk, because if you don't, it's not going to help the document. That's not maintaining stay on its own. Then we need to follow a prompt in there, so what are we asking it to do right now? Very likely we want to pass in some relevant information so that it's able to answer them correctly. And it's also interesting to know that we have that kind of empty space left in our memory to make it generate the answer. So if we query this entirely locate 4,000 token windows and stuff that we have 4,000 tokens of kind of instructions on what to do, we will now have space to actually generate that. Actually, now this is becoming the space is becoming less of an issue these days. Context windows are starting to become like 700,000 millions of things, but we're still being charged by usage on a token basis. So we don't want to just go crazy and pass the whole library of context on every request. Let's say like you figure out what's relevant. That's usually not a good idea. So it's still even though the context sizes are getting bigger, it's very often relevant for us to try to be mindful of how we use that. All right, so that's kind of just kind of. Then if we want to start augmenting that with some relevant information on our own, it's actually we need some persistent storage where we can store the information or we can look it up very efficiently. So to look at that, it's very good to understand kind of what's large language models, knowing what they know. So one thing we know is all the content they've been trained on. Big models like OpenAI's ChatGPT or Gemini, Logline, all these kind of models that are being trained for like hundreds of millions of dollars. They've been trained on all of the internet on the fine. Smaller models are trained on smaller sets of information. So that's something to keep in mind. The other thing that they know is what you give them as part of that purpose. So you can pass them relevant information through that. And that's really kind of handy if we start looking at how do we teach it more about our specific interests. So again, if you have several $100,000 or $1 million, I should say, lying around, creating your own model might be very good, probably not. Fine-tuning a model is very doable. So that's essentially take an existing model and we give it more examples of like your specific use case. So that might be good to like teach it a little bit more about the general like rules of your business or something that's fairly static that really change that over time. But absolutely the easiest and cheapest way to do this is by making sure that we pass the relevant data into the context when you ask them. But this is essentially giving an open test test. So we're saying here, answer this question. Here's the textbook open on the right page. Just read this first and then answer the question. And that makes it answer really, really well. So that kind of gets us to the question of like, how do we make sure that we find the right page in the book to give us? So for that, we're going to take a look at how we can utilize the vector database to store and retrieve information. So we're going to use our terms of service document. It's very small in our case, but kind of general idea of what we're doing here is scalable to any number of documents inside the document. So what we ideally want to do is we want to take our documents, split them into meaningful sections, smaller pieces, and use an embedding, use an embedding model to generate a vector representation of the meaning of that text. And that's very strange if you haven't run into that before. So what I like to use as an analogy to explain what's happening is a color picker. So everyone here has probably used a color picker at some point, but we know that you can choose any color on the spectrum and you get a vector value. And you sort of intuitively know that two color values that are very similar in color are going to have vector values of red, and blue that are very similar. Likewise, if you have two colors that are very far apart, they're going to have very different vector values. So essentially, we're doing the same, but on a much more complicated plane with text. So we don't need to know how the embedding model works. We can just trust that it takes the meaning, the semantic meaning of this piece of text that you get it, and gives a vector representation of it. And the reason why we're going to split up the document in relevant sections is otherwise, if we were to pass, say, the whole document to the semantic model, and we would probably give us a vector value, but that would be equivalent of us asking what's the color of this entire image. And that kind of dilutes the point of that, because then it would give us a equally meaningful answer. So if we can somehow figure out how do we split this text into relevant sections, that's going to be a much more relevant answer. For instance, when I did this earlier with our documentation, because it was the markdown from last week, so I was able to use the headings to kind of figure out, well, we can have the headings probably going to be sort of related to a similar thing. So you can sometimes, depending on the format of the document, you can figure out some strategies on how to split it up. All right, so we have the text, we have their vector values, we put them into a vector store, we use a database that is good at storing and doing vector map. And when a user then comes in and asks us a question, what we do is we take the same embedding model. Again, that's what takes a piece of text and turns it into a vector representation. So we use the same model to get a vector representation of that. Then we ask the vector database to give us the most similar pieces of content that we have in there. So in this case, we can imagine that if we ask about the cancellation policy, which meaning it will have something to do with cancellation. And when we ask the database for what are the things that are most similar to cancellation in your database, it will give us the cancellation policy document out of those three pieces of text we had in there. So that's what we're going for here. Again, we're using the idea to exactly know how this works, but it's really to understand kind of on a higher level what we're going for here. All right, so then finally, if we go to that kind of last step that we're going to cover today, Copilot, we want to add some tools to it. So we want to give it the ability to actually access some functionality of our program, whether that's to look up stuff or to actually perform actions. So essentially, how this works, like if we look at the communication between our user, our application, and the LLM here. So what happens is that together with our prompt or whatever we use it for them, we're going to tell the LLM, okay, by the way, you can also use these functions. So somebody asks about their booking details, and the LLM to call their booking details or get booking details method here. It will then reply saying, okay, can you please run this method with these parameters for me? And then on our server, we can access that method and pass in the answer. And then at that point, the LLM has all the information it knows about the booking and it knows about the questions, let's say, that you have an answer. Then, quick word on the UI before we look at the next code there. We're using again the Hilla framework from volume. So the other say first web application React on the front end, Spring View on the back end. What it gives you is a big library of UI components, so you can kind of all the blocks that you and then instead of kind of putting stuff together out of dips and CSS, so you can put something that's big like that data where it's not what's that stuff. Everything's made to be very customizable, so you can change the look and feel set to fit whatever you're building, and everything's exposed as reactive. So if you want to build a data grid, you use simply data grid. What's different than you'll see when we open this up in our ID is that it has file system makes relevant. So within our Spring Boot project, I was putting React components in the use folder. They're going to get mapped to routes with the same name as the file we have. So we don't have to mess with several router configurations. And What's also interesting is how we call the output. So by taking the Oculus Spring service and adding a browser call or application on it, we're telling them that we're going to call this from the browser, which means that we can then call a method with the exact same signature, same type of information in the browser. So if we were to change the backend API for whatever reason, we actually get some compile time errors and not yet. So it's like a full back end to it, I'd say. All right, I think that's enough theory. Now we're going to jump into the fun part, which is actually building this. Before we get there, I'm going to bump up the front here. Somebody in the back row, can you give me a thumbs up or down on font size? You think it's bigger? So. Okay. Go 150. Yeah. Good. All right. 670. Well, if it's not good, just let me know. So I have a full starting point here because there is stuff that we don't need to get into here. It's not super relevant to the basket. What's good to know though is that we are in this pretty new project where we have pulled in some dependencies, like we have the volume Spring Boot starter, which gives us the Hilla framework. We have a LangChain4j Spring Boot starter, which is going to give us everything LangChain related. Specifically, we've pulled in the OpenAI starter. So LangChain offers us an abstraction over these different LLMs. So in this case, if we pull in OpenAI, we're going to use AI. If we instead pull in a different dependency, we would use Gemini or something else, but we still have the same API. And then I pulled in a local embedding model. Again, the embedding model is what takes piece of text and it's effective language data. Then if you take a look at what we have in our source folder here, we have essentially two things here. We have a front-end folder, that's where our front-end stuff lives, and then we have a Java folder, which is a standard Spring Boot application. So nothing very special here. We have a service class here that provides looking details on flights that we have in our database. It's actually not in the database, it's just like listed in memory, but that's not info here. We have two services that we're going to expose to the client. One is just going to very simply returning all the looking stuff we have, and that we're going to use to always display kind of the current state of the database, and we see when we're interacting with AI how it's actually modifying the database if it is. What we're going to be working on is this assistant service. So again, this is a browser callable service. We'll call it from the browser. It has only one method right now called chat. It takes in a unique chat ID so that your chat and my chat can have separate chat histories, and then that's the message. Right now, it just returns hello there, number it's not picked up, and so on. It returns a flux of strings. Is somebody here not familiar with a flux as a data type? Yes. Right. So a flux is essentially something we can subscribe to, and whenever a new value gets published on it, we get notified. So essentially, instead of returning the entire result whenever it's done, we can tell that we're interested in getting the results at screen just as they're coming along. So this gives us the ability to be able to simulate these kind of user experience, like in Chatbot for most online reactors where it's kind of writing stuff out it's getting generated. And the reason we're doing this is that if we're generating very long responses, sometimes that can take 30 seconds a minute. And that's not really super great for the user. It's looking at that straight for half a minute and things are happening right now. So this way we can start showing something usually like milliseconds, and that makes it a lot better. Enjoyable. All right, so let's go ahead and run this. Let's see if there's something else. Let's see what I have read. So when we start a application, it's going to automatically start opening the browser for us, and you'll see a little spinner there saying that it's building the front end for us. And then we'll get something like this. I forgot to show you what that looks in code, so like you said, we're not gonna get too deep into this, but just so you have an idea of what's happening. So a React component, if you're not familiar with it, consists of two things. So the first thing is a state of that component, so that could be anything from just primitives to arrays to anything, just like what is the model of this component. In our case, we have that ID, which is a person. We are tracking a Boolean, and are we currently working on a response that we can prevent the user from trying to send several requests at one go. Then we have one array of the current bookings in our database, and one array that is all the messages that we have back and forth. We then
What is a nanoid?
what's that?
A nanoid.
Nano ID. So Nano ID is a node library that generates new IDs. So that we're using for unique identifiers filled out
Okay,
for the chat.
that's part of React.
No, that's
Yeah, that's a separate component. Okay, okay, good enough.
Then the other part of this is the template that we bind to this thing. So whenever the state changes, React will automatically re-render this template based on it.
Mhm.
So we have a split layout on the top level here, so we can.
I think you added an X
Yeah,
somewhere.
I did. So a split layout allows us to just reset strings as we. Are we good on the size again? Yeah. Right, so we have the split layout there, and within we have two things. So we have a grid, which is bound to that array of bookings, and then we just define the paths that we want to have visible as columns here. The other part is a message list, so that's just a component that we have display messages, and the other is a message input. And when we send a new message, what we do is we set the working state to true. That's gonna disable the send button while we're doing it. So if we send something right now, we're gonna see grace out until that message is received. So that way we don't have to keep getting sent a bunch of times if it speaks slow or something. Then we immediately add our own message so that the user gets a quick kind of this quickly sees that something is happening, and then we call the backend service that we define in Java, passing in that chat ID message and subscribing to that. So you're saying that on every token that gets generated, we call this. So whenever the first token is generated, we add a new message with that token, and then for every following token, we speak and to that message and then. Good. All right. So we were able to see that it's now returning all the contents of our flux there, which is not super impressive. Doesn't use an AI in any way at all. So let's go ahead and actually start building this out. One thing that's important to see here is that within the application properties, I defined two properties for LangChain, one being my OpenAI key, and the other one is which specific model I want to use. So if we don't specify these, it's okay to start. I've also added some debug stuff here, so we can go into our log and see what's happening, what's actually getting passed back and forth if something were to go wrong. Here. All right, so the first thing that we're going to do is we're going to define an interface that we want to use to interact with the people we have. So very similar to how string data works, where you define, say, a JPA for interface, and string data actually, when we inject that string data provides that implementation for us. We're going to do the same for AI. So we're going to define what is the interface that we want, and LangChain4j will then actually inject a working version of that. So we're going to go into our service class here, our package, and we're going to create a Java class, which is an interface, and we're going to call this our assistant. We're going to give this an AI service annotation, so LangChain4j picks it up. We're going to return a token string. So whenever we call this method, we want the string of those tokens that we can get out of it. We could also return a string here, and that would work as well, but then it would do it for the entire response to get generated before we get it. So we're going to token string, and we're going to call this cat. We're going to take two strings, one being the text ID, the other one being the user message like this. I'm gonna have some annotations here, so I'm going to know what these are, so this will be our memory ID, so which we have these specifically to the chat memory that we're set up in the pin. And the other one will be the user message. So with nothing but this, if we now go into our there's that stuff here, so we have some space to work. So if we go here and inject now a new instance of this, so I'm going to create a private file systems, system down, and create constructor, but it's that injected. You can go ahead and start using that here. So there's a little bit of a mismatch here between string data types and LangChain4j, where LangChain is returning the stochastic string, which is very specific to LangChain, and string expects something more common like a class here. So we're going to do a little bit of mapping. I was talking to the author of the LangChain4j library, who said he's going to add support for this recurring flux eventually, not here today. So we're going to do a little bit of kind of plumbing work here. So we're gonna manually create a class out of this, and I'll type this out in the Ox for this. So we're going to create a string that has many values like a string. Then this will be great. So what this means is that the sync is a way to programmatically produce. It's essentially produced with publish values too. We say that it will have many values going through it. They're all linked to the same person, the other initiated the chat. And for whatever reason, if we start producing more output that we're able to handle on the slides, go ahead and buffer it. It's like don't just drop words in the middle of the sentence, because that would be super confusing to the user here. And then we can return the value of that same as a plus. So in between here, we need to then like whatever we get out of that assistant called the focus screen to our assistant. So that looks like that. So we'll take the assistant, we're going to pass in the chat ID and user message. So those will go down to LangChain, and then we're going to say next. We're going to pass that to the six try next. Complete. We're going to get an event. So it looks like mismatch here between the same thing. The flipping screen, and then error we can say friend, right? And then finally this always forget to actually start. So it's nothing there's nothing that's to do. You forgot to do that. So again, a little bit of boilerplate. There's nothing terribly kind of weird going on. We're just passing space on type of screen, then I will type of screen, and we've done it. We don't have to get it back. Hopefully usually I can do that. Anyway, so what I'm going to do here is I'm going to build a project. So I have string vectors installed, and that's going to just automatically write that it's done. And you should be able to say the value, and hopefully this will now let us know that it's no longer disconnect the brain, but it's actually a language modifier in the name. Now that's all good and well, but that's not actually what we want it to do, because for this context, we want it to actually be customers representative for us to, which should not necessarily like this. But this is where the system message comes in. I've created a little bit of prompt here, and we're going to go ahead and tell our assistant who it is. So we're going to pass on the system message using the multi-line string here. And what we're telling it is that you're a customer chat support agent for an airline fun air. You should be friendly, helpful, joyful. You're telling it what's interacting with the customer through an online chat system, because I have your issue where that's putting me on the road. It really like it went a little bit too hard on that customer support agent there. Anyway, so then we're telling it like before providing information about booking and canceling, it needs to get the first name, last name, booking number, and if we're changing any bookings, it needs to look at the terms of service to make sure that those changes are allowed. And then finally, we're passing the today's thing, because again, well, one doesn't know anything about anything. So a lot of the things that we want to do are depending on the actually apply to this. kind of time span. All right, so we're gonna build this again. And see if that works. Now I'm gonna save this option type, so I'm gonna use the rotation feature here. Okay, it works. Right there, my name's Marcus. So now we can see it's already like it's talking about like bookings and stuff. So it knows who it is. But the problem here is that it doesn't know, and it doesn't have any memory, right? Like, we're talking about that stuff that we use out of the context. So one of the things is my chat history. So if I were to ask it now, hi, I think I forgot my name. Do you remember what it is? Hi, it seems like I forgot my name. Do you remember it? So, yeah, it's going to be helpful, saying, I don't remember your name, but maybe you have a good one, work on it together. Super helpful, but not really. So that's where we need to kind of start putting some of these pieces. So I'm gonna create a configuration class for us here. Make all this, then change the config. And this will be a string configuration class where we can configure these. So as we're configuring these, making them available to the dependency infection context, LangChain, notice that they're there, and that's going to start using them. So if you create a new bean here, that will be a depth memory provider. You know, call this a provider, and we return a lambda that will depth ID as its input, and then it will return a token in the chat memory. Right. So 1,000 tokens. And you need to pass a tokenizer. Thank you. So now we're saying, okay, let's use thousands of that chat for that context window for memory. And the tokenizer here is different depending on which model you use. So like just injecting the tokenizer is how it counts. So this gets value not really use. So if we now go ahead and build this and go back here and try this again, hopefully have a slightly better success here. Hi there, my name is Marcus. Do you happen to remember my name? Actually, we are. Given up to memory. By kind of making that supplementary provider available in the defense context, use that, and now we can use it. Now, what it doesn't know is anything about our business. So if we were to ask something meaningful, like wrong one. Which phone cancellation cost would be increased? All right, so we've got something that sounds very let's look up thanks. But if we were to go and look at our actual terms of service here, the legislation has nothing to do with our specific terms of service. So this is probably a good.
This is not unlike the answers I've gotten when I've called representatives live
So
for
this
AI.
is probably a good approximation of the average of all the cancellation policies of all the companies in the world, which is not super helpful for us. So what we need to do then is what we were looking at, that how we want to split the document into pieces and put it into a vector database and do all that. So let's go ahead and do that. We're going to do that in the same config file here. Let's go. Good. I'm going to try to do it for the outside of Java. So we're going to create a couple of these here. One will be an embedding model. Again, the embedding models will take the string into the vector. So we're going to tell LangChain4j this is how we want to turn strings into vectors. So we're going to return new embedding models in memory or in JVM embedding model. So very simple, but nothing too fancy. We could use an OpenAI's embedding model or something fancier if we want to realize that this way to number of API calls we need to do. The other thing we need to define is so we can take a store. So this is the vector data is really like store use. The embedding store will have segment. We're going to store segments of text in this list. And we're going to call this up embedding store. And we're going to return. So in this case, I'm using the memory and JVM 13 of these. If you were building something more robust, we would probably use something like hoping you guys are making model or like PG vector or Python or any other actual vector database. The good thing is that these are interfaces, so we can start with one locally and then switch it out to one later on. Good. All right. So we have those. Then we need to go through that whole reading the documents, split it, stuff. Normally, in a real life situation, we would not do that in the application that consumes the information. We probably have a build server somewhere that kind of notices whenever your documentation changes, and then I guess reading inspectors for that piece of documentation. But since we're building
standalone demo here, we're going to do everything in one place, but just to be very clear, this is not typically something you want to do on every app startup, because that would kind of be just unnecessary work. So we're going to define a bean that's a application runner. So that's just going to get run whenever we start this. We're going to call this our ingest docs, and this needs to return a lambda, takes arguments and does something. So we're going to pass in a couple of things here. First of all, we need that embedding model that we use to turn strings into vectors. Then we're going to have the embedding store where we store all of them. So embedding store. And again, these are going to be text segments like this. Then we're going to have a tokenizer. So we know how kind of big the chunks are that we're splitting into. And finally, we're going to inject that actual terms of service document that we have. So I'm going to use a value annotation here, say that on my class path, I have a terms of service.txt file, and this should be a resource called terms of service, like that. So what we want to do here then is we're going to use LangChain's file system loader to load this the actual file, and then we're going to use its document splitter to split it up, and then for each go through the steps. So we're going to create a var for the actual document, and we're going to use the file system resource, no, file system document loader dot load document, and this expects a path. So we're going to take our terms of service resource, we're going to get the files path from it, like that, which gives us then a LangChain4j document. Then we're going to create a ingester, which will be an embedding store ingester. They very much like the builder pattern, so we're going to use that. And here we're going to define the whole pipeline of what we did in the slide. So we're going to say that the document splitter should be a document splitters.recursive. I'm going to explain this in just a second. We're going to split it into 50 character or 50 token chunks with no overlap using our tokenizer. So a recursive splitter essentially tries to fit everything into that number of tokens that you gave. If whatever paragraph is bigger than that, then it will recursively split it into smaller sections until it is able to fit it into there. Then once we've split the document, we're gonna, for each one of those parts of the document, we're gonna run it through our embedding model to get a vector value. And then finally, we're gonna save those into our vector store. So this is essentially our pipeline. We split, generate vectors, store them into a vector database, and then finally we use our ingester to actually ingest the document. So that's the pipeline. It's a lot of typing for one document, but you could obviously run any number of documents through here. They have a convenience loader that just takes in a path to a folder on your computer and then just figures out based on file type what type of file it is. And so if you just want to do like a cool demo quickly, you could use that. But I wanted to, for kind of educational purposes, run through all the steps so There's no magic going on here. So again, this would likely run somewhere entirely different. Just save it to a vector database, and we're connecting them to the same vector database in our application here. So the way we actually access that is through a content retriever. And that needs the embedding model and the embedding store. No. Text segment, that. So the content retriever is what gets run when a user asks a question. We take the input question, we run it through the embedding model. So we get a vector for that, and then we ask the vector store to retrieve documents that are similar to it. So what we're gonna return here is a embedding store content retriever, and then we're gonna again use the builder here. So we're gonna take the question, we're gonna run it through our embedding model. We're gonna search from the embedding store for similar documents. We're gonna get a maximum of 2 results in our case, and we're gonna say that they should have a kind of relevance score of at least 0.6. So these are numbers that I played around with and work here. You probably need to play around with your own numbers to figure out what makes sense and how many documents you want and so on. But just to kind of show you how this works. Again, there are convenience methods for doing all of this in one go, but just to be very explicit in what we're doing here. Okay, so now if things went well, if we typed correctly, we should be able to go here once it reloads and ask it for, no. Hi, can you explain the cancellation policy to me, please? All right, so now what we get is actually in line with what we had in our terms of service. So we see cancellation fees 75, 50, 25. There's 48 hours before a flight. So that is exactly what we have here in our cancellation policy. So that's good. Now we're kind of on the right track here. Now the next problem is, now that we're kind of in this RAG state of the progression, is that it still doesn't know anything about our specific booking, or can't say, am I allowed to cancel or not, or can I change my booking or not? So this is where we need to introduce some tools. And with LangChain4j, that's super easy. So what we're going to do, we're going to create a new class here. I'm going to call this my booking tools. And I'm going to turn this into a Spring component. And then I'm just going to define a couple of methods here that I want to have access to. So I'm going to, first of all, inject that flight service here so we can call some methods on it. And then I'm going to define 3 methods, one for getting a booking from the database, one for changing it, and one for canceling it. So public booking details, get booking details. And if you remember, we asked it to always ask for 3 pieces of information: booking number, first name, and last name. So those are the things that we're going to use here. String booking number, string first name, string last name. And of course, we're doing an AI talk, so we might as well have an AI implement this for us. It's not super good at knowing what's there, so let's see if we actually go back, and then we're going to open up the flight service here. Sometimes it helps if you just have the file open in another tab, and it'll kind of be able to use that as its context. So let's see. No. All right, so we're going to cheat here and actually get the correct method signature from here. So for changing a booking, we're going to ask for the same things, but also, is there a new date? So do we want to change it? Do we want to change the from and to destinations here? And we're going to pass those to our flight service. And then finally, we're going to do similar for canceling the booking. The only thing we need to do here then to make these available to LangChain is annotate these with a tool annotation like this and build the application. And hopefully, if things go well again, we should be able to interact with these. So the way I've set up the test data here is that the people who are up top here, like John Doe, is too close to his travel. He can't make any changes, whereas somebody here towards the bottom, like Robert or Sarah, is hopefully able to make changes. So let's see what happens. And we're going to be very actual users, so we're not going to give all the information up front. So it has to like keep asking us for things and try to make this somewhat realistic. So, hi, my name is John Doe. Can you pull up my booking details? All right, so now it realizes that it's missing the booking number, so we need to provide that. No. It's 101. It's 101. All right, so got our details here. Looks about correct. So we're flying apparently from Berlin to Los Angeles. Can I cancel my flight? All right, so no deal. Today's the date of your flight. Can't do it. Not happening. So seems good. All right, let's see if we're Robert Taylor. Hi, my name is Robert Taylor, booking number 105. I would like to change my flight to go to Newark, New Jersey instead of LAX. All right, so let's see. Before we proceed, need to fetch the details. So this is what I said it was doing. Sometimes it's putting me on hold, which is really weird. Then you type OK, and then it continues actually doing stuff. So if anyone's into prompt engineering, you could probably, I've tried all kinds of prompts, like telling it not to put people on
What happens
hold.
if I swear at it about it?
Well, we'll see. Anyway, so now because we're flying in economy, there's a change fee. Obviously, we're not taking like fare changes or anything into consideration here, but it does kind of, because we said in that prompt, like if there is a change fee, you have to make sure that that's okay. So in this case, would you like to proceed? Yes. And hopefully then we should be able to see this turn. So again, we didn't have to know the airport code or anything else. Like the LLM knows that perfectly well, but it didn't know about our specific context, which is our cancellation policies and change fees and all of that. All right, so I mean, spend a little bit of time building this application, but I think like considering how little time we put into it, we were able to still build a fairly meaningful application that does quite a lot and hopefully shows you that like AI goes well beyond just generating funny pictures and memes. Where I think the power really lies in when we're able to leverage it in our actual applications to do stuff. Like it's probably not going to be nearly as flashy as a lot of those AI companies are doing today. But if you can just kind of have an AI take over part of a workflow that's currently super time intensive for somebody that's very error prone because it requires ingesting a lot of information, like that's something that AI is exceptionally good at doing. If you feel like playing around with this demo, you can find it here in my GitHub. I've implemented the same demo in different branches with Spring AI and Semantic Kernel as well. So if you're interested also in seeing how different Java AI libraries compare to each other and how they're different and similar, it's a good place to explore that. It's been a fun collaboration where I've actually worked with people from each team. So the LangChain4j team has contributed stuff to the LangChain branch, and the people from the Spring AI team have contributed to the Spring AI branch, and the Microsoft team has contributed to the Semantic Kernel branch. So it's a pretty fun little playground to check out how AI and Java work together, and that's something that I keep updating. So that is it for me in terms of me talking. I would love to answer any questions you might have, go back to the code and show stuff, or anything else that you might have on your mind.
If you have a question, let me know, and I'll bring you over the mic so that the people on the web can hear it. I have a question. I'm going to start off. You may not, I don't know, this business about tokens.
Yeah.
nobody ever tells me why, there's no semantic meaning to the breaking up of tokens, right?
No,
It's just a certain number of letters.
not even that. It's based on their frequency in natural language. So it tries to be very efficient in how it numerically represents
Okay, all
text.
right.
So like letter combinations that are more common in language will have like a smaller number, so they're more efficient to.
Gotcha. Okay, all right. Yeah, slowly, these concepts get clarified for me.
Yeah.
Right. Other questions? Any?
Yeah, I got, like, to get the tools, you, in the code, what you did was you annotated them with @tool.
Yeah.
How did the language model know that it was, that it had the tool available?
Very good question, and that's something that I completely forgot to show you, and that's why one of the reasons I put on that debug. So if we actually look at what goes back and forth between us and like what's the JSON going to the model and stuff. So let's go back here a little bit. All right, so
How
here,
did it call,
yeah,
recall the booking record instead of canceling the booking record when it was responding to a chat? I mean, it knows that it has one tool to cancel a booking, and it knows it has another one to recall the details. How did it know which to call?
all right. Well, let's take it in two steps. So one is like, if we're looking at now, this is where I answered, yes, I want you to make the change. So you can see that it, first of all, it sent that whole history to it. So we can see like all of the messages that we've had up until that point are all sent with it. Then we're passing in, let's see here. Here we have an array of tools. So we're telling the LLM, like, here is all the different tools that you have available to you. So one's name is change booking, and it takes in following parameters: first name string, last name string, and so on. And like all of them are required essentially. So we're describing the functions that are available to it. The second part of the question, how does it know which one to call? In this case, we were just kind of relying on it, looking at the method name and the parameter names and figuring it out by itself. If you look at the GitHub repo, you'll see that I added actually, so here I've actually added a description where I give it a little bit more information about what this particular tool does and how it should be used and what's expected. For this demo, I know that just giving good enough method names, and we have few enough of them, that it will figure it out on its own.
Yeah, because it doesn't, it's surprising to me that, you know, like, for instance, the first tool that it uses is to look up the booking number. Booking number isn't a real word, and neither is get booking details.
Yeah.
But it still figures it out, because when it tokenizes, it tokenizes that and says get booking details is not a word, but get is, and booking is,
Yeah.
and details is.
Yeah.
Yeah.
Yeah. So it's pretty good at figuring things out. So really, like, that part of the equation is handled pretty well. Like, the language models are super smart. They're getting smarter by the day. But really, like, where the interesting part is, like, how do we actually use them to do something that's specifically kind of relevant and interest to our company or business or hobby project or whatever we might be doing.
Somewhere along the line in the system prompt, or maybe LangChain did, it told up in the context, it said you have these tools to use. It must have.
Yeah, that's what we're looking at here. So here's the entire body that we're sending. So we're like, and this is going to OpenAI's chat completion endpoint. So it's saying model, here's the message history, all of the messages that we've had back and forth. Here's the latest message. So the asset at this point, our assistant is telling, or we're telling that we want to call get booking details with these specific details. And then if we look at what's also sent with it is the list of all the available tools. So they're not in the system prompt, but they're always kind of appended to each call. So in this case, we we just define them through those annotations. Like in other cases where you're doing a more meaningful system, you probably don't want every function call to have the same tools available. So you'd be more explicit and just pass like, here's the specific tools I want you to have available when you're dealing with bookings, as opposed to, I don't know, something entirely different. So in this case, we only have 3 methods in the entire application. It's a simple one, but for instance, Spring AI requires you to be much more explicit when you're calling, or in each call, you need to say, like, I want these specific 3 functions to be available.
Oh, here we go. Okay. I'll work my way up.
So looking at that screen right there, I saw the temperature for the input to the model.
Yeah.
Have you tried playing around with different temperature values to see if the hold issue either goes away or comes more frequent, or just to see how its responses change?
That's actually a good point, like having a temperature of 0. So like reducing the randomness of the answer would probably be a good idea in this case, because we're not looking for something like very artistically creative here. We're looking for something that's more like closer to deterministic. Like obviously we don't expect it to be fully, but it would be good if it's like at least like from one day to another, it would basically work the same way.
Yeah.
Yeah, I noticed that it was mimicking the kind of formal speech that a customer representative gives. That was interesting. It was.
Yeah. I mean, it's obviously not very realistic. We'd have to say like you're cranky and sure.
No, it was realistic in that way.
Yeah.
It was just more polite. It just sounded fake polite.
Yeah,
That's what
exactly.
customer representatives sound like.
Yeah, good.
Okay, all right, I'll come up here. Oh,
Hi, Marcus. By the way, nice presentation. I just want to know, I saw that when it queries when it sends the request to the OpenAI, it sends PII data, like first name, last name, and now.
Yeah.
So is there any way for us to avoid that? Because there can be other sensitive data also related in our database. So I just wanted to know.
Yeah, I mean, if you want to avoid sending data, really, that's more of a like, where do you host the LLM? So if you have personal information like we have in this case, like you might not want to send it just to like OpenAI. And
yes.
So more likely you would probably either provision some sort of private, like through Azure or something. You could have a version of that running more privately. Models like Llama are becoming increasingly sophisticated. So if we wanted to, we could actually I don't know if LangChain supports function calling with Llama yet, but theoretically, like if you run like a local model through like Llama, you could actually run this whole thing just locally on your computer as well. So really the answer is like you need to have the LLM in that case in an environment that you trust, so you're not kind of exposing stuff outside of where you're comfortable.
The other question is like, can we use some sort of a token instead of sending the first name and last name? Like we can either tokenize the first name and last name and send to the LLM and get the response.
You could certainly, but then like you just have to make sure that your kind of business logic actually then turns that back into it. So you can certainly do that. Probably the best idea is to never just send anything that could even like. But yeah, certainly you could do that.
Thank you very much. Thank you. That's what I want.
Yeah.
anything else? Any other questions?
I'll be hanging out here afterwards too. So if you have any questions or something that's more like not for the whole class, but just
cool.
interesting question you have, you can.
Thank you.
feel
This
free to
stuff is
come back.
always exciting. I'm going to get Mike back on the line here. And Mike, you can, yes. Ooh.
Thank you.
All right, I'm going to get Mike back on. Hopefully he's
Yeah,
awake.
I'm here. No, I've been running around a bit, but I have to say, Marcus, I didn't get to see everything from your presentation, so I'll definitely watch it, afterwards. But I have to say, some of the chat features in some of these websites are nothing. What you presented tonight is orders of magnitude better.
We missed a couple of things that you said there.
Oh, okay. We have. Okay, there we go. I'll repeat that real quick. So what you presented tonight was orders of magnitude better than some of the chat features in other websites. So they need to hire you. So yeah, in any event, let's wrap up here. Believe it or not, our contractors are still here. So, and I thought I had the Zoom page. Okay, hold on. What am I doing wrong? Oh, wait, maybe it's here. No, not that. There we go. All right, can you guys see that? Yes? Okay. Okay, so just to wrap up, okay, so Dev2 Next is later this month out in Colorado. This is the first conference organized by Venkat Subramaniam. He actually had one back in 2019 that was all ready to go, but then, or actually maybe it was 2020, early 2020, but then COVID hit. So anyway, I think Chandra's going to be out there, if I'm not mistaken, if I read some of the stuff online. The Open Community Experience, or OCX, which is formerly EclipseCon, is in Germany. If you have your passports current, want to see Mainz, Germany, then check that out. And then IDPCon, which is Internal Developer Protocol or something like this. This is the first I've heard of it. The person he used to be with Gradle, and Justin Roque. Anyway, he reached out to me. He offered me a free ticket. However, that date is my wedding anniversary, and obviously going to a conference on my wedding anniversary would not be the smartest move on my part. But if anybody's interested in going, you could take my free ticket. So he offered that. There is a discount, 50% discount if you're interested. Check out the website. Then they have all the speakers and everything pretty much all set for the conference next month. QCon San Francisco is in late November this year, or about a week before Thanksgiving. And, in a moment of shameless promotion here, I was asked to provide a workshop, which is really cool. So I'm looking forward to that big time. So that's that. Upcoming events for us. Next month, we have Scott Strohs, who's going to present using MySQL Document Store with Java. MySQL Document Store is very similar, I think, or sort of equal to MongoDB. So, MySQL is a relational database, so they've gotten themselves in the NoSQL world. And we have Rajiv Shah in November talking about unified real-time data processing architecture pattern for multidimensional data problems. And then in December, we have Amol Gote talking about digital signatures decoding. And in January, I have an abstract and a title from Scott Selikoff called Certified Java, Everything You Ever Wanted to Know About New Features in Java 21 and Were Afraid to Ask. So that's on January 14th of next year. Friends of ours, here's building a custom AI chatbot with Spring Boot, React, and Lang4j. That kind of sounds familiar. So actually, Marcus will be visiting the Philly Jug tomorrow. And then the Chicago folks have Bob Paulin, who's going to present polyglot pipelines with Apache NiFi or NiFi. And then Vlad Zakharov, some of you may know from the New York group. He's going to talk about data frames in Java. He presented this, I think, back in June. And then in the Boston area, Johanna Rothman will talk about need to convince management how to build a business case. So that's it from all of our friends. The others either don't have anything or had theirs before. And that's it. So it is definitely time for one of those meaning those pint glasses. So, but yeah, appreciate everybody coming out tonight. Again, I apologize for not being able to be there with you. So, but yeah. And so we will see you on October 8th. Thanks a bunch. And thanks, Marcus.